Hi, my name is Eric. I've been working in the aerospace industry for a couple years now, and I found a cool little problem that could be fixed that I was able to fix. So, the easiest way to understand what I'm talking about through a controlled lathe system is watch this video. We're going to create an object and then we're going to put a chamfer on this object. And this will give us a better understanding of what the problem is that I was encountering and how exactly it was solved. So I'm going to play this video, talk to you about it as it's playing. Down in the bottom corner, it's just a little repeating thing. That's kind of what a lathe does, is it spins something around and it cuts it. So I know it's a little bit hard to see, but this is Fusion 360, and I'm in here inside of a sketch, and I'm creating a circle at diameter 3.5 inches. So after I create that diameter, I'm going to extrude it, bring it up half an inch. It'll be fine. I don't really want that ring, I'd rather it be a solid block. So just bear with me here. It's easier to create, basically we're creating a solid cylinder. Here we go. Okay, solid cylinder about ½ inch long. Oh, hang on here. The butterfingers. But basically we're going to create a solid cylinder here, and we're going to extrude it, and then we're going to generate a 45-degree chamfer on its edge. It's easier just to start with a solid cylinder here. There we go. Alright, so let's get this easily oriented here so we can check it out. Go over to this corner. So yeah, I want to explain, this is the easiest way to explain what a 45-degree chamfer is, so that we can understand the problem. Here I'm selecting that edge, and then I'm going to go up top to my tools, and I'm going to create a chamfer. Well, not a fillet, a chamfer. Okay. If you can see in that little box, I'm generating a length on this chamfer. And so this type of chamfer that I'm putting on, it's the length of the chamfer, which is the vertical length of the hypotenuse, and then I'm asking it to make it a 45. So that's basically what we're generating here. It's basically like you know, if the edge was sharp, the the longer the chamfer, the duller the edge will be. So this kind of goes out mathematically into triangles. So basically, after this video is done, after I explain what a chamfer is, we're going to talk about the trigonometry here. So I took the liberty of plotting this out. This is our dimensions here. If we put this face down, let me zoom in. So if we put the ring face down, it's ½ an inch, like I said in the video. And then I've labeled this 45 degree, and then I've labeled the face of the part to the front of the chamfer where that edge ends. So that's 0.45 inch, and then I've labeled this, which is the length of the chamfer, which is 0.05. I've also labeled the top of the of the outer diameter, which is 3 inches, 3.5 inches, as you can see over here. And then you can see that the bottom of it is 3.4 inches. So it's 0.1 of an inch length down its slope. So one of the problems of machining and doing things like this is when you get something and really can't afford to waste material or waste parts that someone else has already put their labor into. You would want to use a program. So sometimes on the prints you don't know what the length of the chamfer is, so it kind of makes a snag when you have to write the program to make something like a 45-degree chamfer on a ring. So instead of guessing and wasting material and wasting time, I decided to develop a program that I like to show. Okay? This is a simple Python program, which is really great. I can go and start my program. Zoom it in here. Okay, so I'm starting my program. Let me put it over here so we can have some of the dimensions in front of us. So I'm starting my program, all it spins up and it says enter the top of the chamfer. So when it's saying this, the top of the chamfer, what I need to give it is the x value, which is the diameter of the cylinder. So the diameter of the cylinder is 3.5 inches. So I'm going to type in 3.5 inches. Now it wants to know the bottom value. So I will go, the bottom value is 0.34. So I'm going to type that in. 3.4. That's the bottom of the chamfer. Enter the tool nose radius. The tool nose radius is the angle on the tool that you're using to cut the material with. In our case, we're going to put 0 because we don't need to add any more complexity to the calculation. So I'm going to enter 0, and then here it's asking me enter the W move, Z-axis depth. So we already entered 3.5 and 3.4 in my chamfer value fields. Those are x values. Those are diameters of the cylinder. So Z move is how long the chamfer is. That's why you can tell on the screen that I labeled it here. Say the length of the chamfer is 0.5 minus 0.05. So that's a total of 0.05. So I'm going to enter the W move, which is the Z-axis depth. So let's see here. Go 0.05. Okay, so my response here is enter chamfer. The required chamfer angle for the given W move is 45 degree, 0, 0, 0, and then 3 degrees. So this way I can run this program when I'm running at my machine, when I'm doing my thing at work, and I don't have to waste material, and I can optimize my program as needed on the machine running numbers through this system. Normally you have to cut them on a machine and go to the inspections office and then go inspect your part and come back to the result and go back or get the result and then go back to your machine and then create your offsets or your change in your program and then repeat. This way with the program you can it can get all the math out of the way, have it auto-generated so that there's no user error, and this way scrap costs go way down and you're not destroying someone else's a product that someone else put a considerable amount of time and energy into. So that's my pitch, and hope you liked it. Enjoy. I hope to see you guys again.